Hello everyone, meteorologist Rohan Shroff here. It is February 22nd, 2026, and we have a potentially historic snowstorm now to track, and with the B word likely being used here. Blizzard warnings all up and down the East Coast, stretching from Delaware up into Massachusetts, with a rapidly intensifying storm wrapping around heavy snow, very strong winds, low visibility, and the potential to be talking in feet of snow for coastal sections of New England. So let's talk about this and let's get into it. So first off here, we have the SPC mesoscale analysis. This is valid for the latest available time. And this is looking at essentially the surface map and kind of seeing what's going on here. We can see we have our low off the coast that's starting to develop here. We have temperatures still in the mid 30s for a lot of central Virginia, mid to upper 30s, keeping things a bit warm. And if we look at the 925 millibar analysis, you can see you're starting to see that signature of your low forming as that 925 millibar temp contours start to sag further south as that cold air advection really starts to take shape, and that wraps around more precip and more snow on the backside of the low here. If we look at also the surface observations, you'll see that still most areas are stubbornly in the mid to upper 30s, which is still a bit too warm to really even see some mood flakes here, and obviously way too warm for any measurable accumulation. But as that low intensifies and as it strengthens throughout the day, we'll see precip rates start to intensify and a gradual change over to snow by the mid to late afternoon or early evening for most of the Northern Virginia and DMV area. Now, if we look here at our satellite, this is our visible water or our water vapor imagery loop. You can see that we have our shortwave trough diving down. The signature shows up quite nicely. It's starting to reach that neutral tilt, going to start to go negative pretty soon. You can see our low starting to form off the coast here. As a result of that, our moisture plume surging up from the Gulf of Mexico here and further south. That's all going to be transported right into New England, especially in these areas right here, setting up the stages for a very impressive winter storm for most of I-95, especially north and east of DC. And if we take a look here, these are our current temperatures. Again, you can see that most of us still are a bit too warm. Our colder temperatures are really kind of focused up in Pennsylvania, New Jersey, New York, still in the mid to upper 30s for the central or the DMV area. And the problem is that the antecedent air mass is not impressive at all. It's a high dew point, not really a cold air mass, and so because of that, to get snow, we're going to have to manufacture a cold air, so to speak, with high and intense lifting, essentially cooling the atmosphere thermodynamically. This system will not be able to rely on any antecedent cold air mass because when you go further north too, there really is not much to work with. You have to really go further north and west to get those much colder temperatures in the Midwest and upper plains, and that is a big limiting factor for the storm. If it was a bit cooler, if the antecedent cold air mass was maybe 5 or 6 degrees colder, we'd be talking a lot more snow for the Northeast and also especially the DMV area, as the rain we're seeing right now would actually be snowfall. So a big key factor there. And just to kind of start back at the beginning here, this is the GFS ensemble for 0Z tonight, and this is the forecast that was initiated a couple of days ago. This was the forecast made on February 17th, or so 5 days ago, and you can see that there was not really much of a signal here. And this is, if you've been following this storm closely, you know that the GFS really wasn't an island, being the only model, the major global model, to be calling for a much more impactful, severe winter storm for coastal areas and population centers. While models like the CMC and European were much more flatter, out to sea, more of just a snow showers type setup, and the GFS was very stubborn, and all the other models started to pick up on that more amplified, more consolidated signal, and you saw just an absolutely remarkable uptrend here, especially for New England in the past 1 to 2 days, where you had an original snowfall forecast for maybe just 3 to 6 inches, and now all the way up to maybe 18 to 24 inches for many spots. So just a truly remarkable trend. And if we go back and we go, iterate through each forecast here, going up to the present day, you can see that with each run, there is just a dramatic strengthening and a westward jog with the overall trend. You can see that the new ensemble has the lows centered almost just tucked off the Delmarva coast here. So very impressive trend, very impressive system. Now, if we take a look at the upper air, we look at the NAM 3-kilometer model, look at the Z500 vorticity, just kind of take a look at what is actually causing the storm synoptically. So if we start back here on Saturday around 1 a.m., you can see your main pieces here. You have a little bit of a shortwave down in California, and you have your northern stream piece of energy over here, like that. And so then as you go through time, that northern stream dives down, essentially merges with the southern stream vort, but the northern stream is the primary driver, reaches neutral tilt this morning, actually, and then you start to see that rapid intensification and deepening off the eastern seaboard. And then you can see it gets negative tilt by around late Sunday afternoon. And then you have a closed stacked low, which just drives precipitation all into New England. Very heavy snowfall rates. And it kind of just spins. And when that happens, that's where you get those really absurd snowfall rates. For the DC area, this occlusion and stacking just unfortunately happens a bit too late. If you want to get those really heavy snowfall totals in DC, you would want this to be further south, that occlusion to happen down over North Carolina, which would dump those really heavy snowfall totals for our area. Fortunately, just not going to happen. But for areas north and east, they're really going to cash in with the system. You can see it just spins and spins and spins. And if we look at the forecast radar, you can see that rain right now, but as that storm intensifies, we change over to snow very quickly. And then it just dumps and dumps for the New England area. If we take a look at some of our dynamics, not the sounding, go to 700 millibar frontogenesis. So this is a really good indicator of where the heaviest snowfall rates are going to be. Essentially what you have is you have very cold air aloft to the west, and then you have that warm air surging in from the southern regions of the globe, from the Gulf of Mexico and the Caribbean especially. And that then clashes, and what that warm air has to do is it has nowhere else to go but go up. And that creates intense lifting, and then where you have that intense lifting, that's where you have your heaviest snowfall rates. And so these contours here, these purple contours, that really indicates where the heaviest lifting and where the most impressive snowfall rates are going to be. And you can see that the model here very nicely picks up these very strong bands forming right off the eastern Virginia coast into southern Maryland, into New Jersey. And you can see as that storm occludes, that band essentially becomes stationary. It stays in place for several hours, leading to very impressive snowfall totals in this area right here. This is going to be your jackpot zone for where the heaviest snowfall totals will be. And that is reflected in the model output as well. You look at the 10-to-1 snowfall ratio. This might be a little overdone with the lower ratios with the system, but you can see 10 to 15 inches plus in a lot of these areas, with up to 24 to 30 inches in Nantucket and southeastern Massachusetts. And if we take a look at temperatures as well, I think I'm covering that here. So I'll show you one more thing here, and that is the positive snowfall depth change. So you can see when you look at the positive snowfall depth change, which kind of takes into account, lower ratios, warmer ground temperatures, etc., your totals do decrease a little bit, quite a bit actually. And this might be a little bit underdone, but it goes to show you that with the warm temperatures, with the marginal temperatures in many cases, that will be a limiting factor. This is very different from our storm that we had 3 weeks ago, where temperatures were in the teens when snow started, which led to enormously impressive snowfall rates or snowfall ratios and a very quick sort of accumulation window. This is going to be different, where a lot of the snow melts on contact for a few hours, especially the further south you are. And to show you just how impressive the dynamics of the system are, I want to show you the snow bands feature, the snow band probability tracker for the HER model. And so as you go through time here, you'll see that as its storm intensifies, those heavier rates really start to build in the I-95 and east in Virginia. And then once that low stacks and gets occluded, boom, you have 2 hour, 3 hour snowfall rates, 2 to 3 inch an hour snowfall rates all along the from New Jersey to southeastern New York. New York City is getting pounded. Massachusetts, Connecticut, Rhode Island, Nantucket, etc. They're just getting smacked with snow, and then that eventually moves out of the area. Now I want to touch again on the temperatures and why, one of the reasons why I'm not too bullish on this storm for especially areas in Virginia, and that's because even in the afternoon, you're still in the low 30s, essentially 32, 33 degrees. And so while you certainly can have accumulating snow with this, you need much heavier snowfall rates to get accumulating snow in these marginal sorts of temperatures. Lighter snowfall rates, the melting essentially offsets any accumulations you would see. Now, luckily, with such an intense system, you are likely going to see some very heavy snowfall rates, which will help offset this. But it shows you that, even at the peak of the storm, temperatures are 31, 32, 30 degrees in a lot of the areas. Once you get further north into New York and further north of that, that's where temperatures become a little bit more favorable, with upper 20s and lower 30s helping with snowfall accumulations. And one other thing is, with the system's strength, you're also going to see very strong winds, hence the blizzard warnings for a lot of the coastal areas. As that system intensifies, look at that, boom. You have a massive increase in wind speeds, 50, 60 miles per hour on the coast. Could really lead to some widespread power outages with the heavy, wet, sticky nature of the snow. You're going to see power lines go down, tree branches snap. It's going to lead to widespread power outages for many areas, especially, again, along the coast. You can see here, even in DC, you can see wind gusts gusting up to 30, maybe 35 miles per hour. Now, if we take a look at the national blend of models, this is the model forecast, the blend of a bunch of different models and what they're showing for snowfall. Now, keep in mind, for the DMV area, this is likely pretty overdone. This is 6-7 inches of snow, 10 inches of snow in the DC area. This is way, way overdone. This is assuming a 10-to-1 ratio and everything sticking on contact. So take what you see here and kind of divide it almost by half, really. And so you can see then overall when you get that picture, you get about 3 to 5 inches here, maybe 5 to 8 inches here, and there's much heavier snowfall totals once you get further north and east. And you can see here that the NBM has a mean of 28 to 32 inches of snow in New York City, a bit overdone, I shall add, but just so it goes to show you that the impressive snowfall rates and the long duration of snow are really going to pile up here. A mean of 32 inches in Boston, 35 inches in Providence. So again, goes to show you it's going to snow a lot in some areas. We could be measuring in feet. And so with that, I'll show you my snowfall forecast. Let me pull up the document really quick. Let's see right here. Forgot to pull it up at the beginning, but there we go. This is my snowfall map. You can see here that I have a general 1 to 3 inches for areas south of Fredericksburg. This includes Central Virginia, Charlottesville. Keep in mind that the ridges in Shenandoah Valley will see much more as that upslope mountain snow, but again, very few people live there, so it doesn't really seem relevant. But you can see here that further north, you get into that 3 to 5 inch zone, so areas like Winchester, your big Nova population centers like Loudoun County, Fairfax County, into south and western Maryland. And then once you get closer to Baltimore, I think that's where we're going to start to get your really big totals. 5 to 8 inches for the city of Baltimore, 8 to 12 just east of that in Delaware, the northeastern portion of the state, and then 12 to 18 inches of snow in New Jersey, northern Delaware, etc. This is where you're really going to see those heavy snowfall rates and very impressive totals. Now, you might notice here the pink dots. This is kind of a band here that I've highlighted where I think there could be a little bit of a boom. 5+ inches are possible. And latest guidance has shifted this a bit further east, so this might have to be moved a little bit further east. But essentially what's happening is you have an inverted trough setup where you have the strong northeasterly winds from the storm converging with the northwesterly winds from the cold air direction to our west. And that creates an area of intense lift somewhere in this area. And that's going to lead to very, very heavy snowfall rates, which will overcome those marginal temperatures, overcome the warm ground, and lead to some impressive accumulations in a very narrow band. And so I can show you that here in the model output. I think the high resolution Canadian model does this very well. If we go further back, boom, you can see that right here. This little narrow stripe of very heavy snowfall. That's going to lead to some people being very, very disappointed because sinking air around that will lead to lower snowfall rates. But people in this band are going to be very surprised to see just how much snow they get if this band does in fact form. And so that's going to be the key forecast sort of wild card here to help overcome those lower snowfall forecasts for Northern Virginia. Whoever gets in that band will really see an overperformance. Just the question is, how strong will it be? How long will it last? And will it actually even form? Those are the main things. These things are notoriously unpredictable, very hard to forecast their exact location. So that'll be the thing to track throughout the day. That's it for this video, guys. I hope you enjoyed. Stay safe in the weather and enjoy the snowstorm.